The recommended wire type for irrigation systems in public park systems with multiple solenoid stations is type UF wire, which stands for underground feeder. UF wire is a single conductor, moisture-resistant wire that is designed for direct burial in the ground. It has a tough outer jacket that protects the wire from moisture, sunlight, and abrasion. The conductor size for UF wire should be 14 AWG, which means American wire gauge. This size wire is sufficient to carry the electrical current required for most irrigation solenoid valves. In practice, contractors may have been using individual 14 AWG wires instead of UF wire because of its low cost. However, individual 14 AWG wires are not as suitable for irrigation systems as UF wire because firstly, they are not moisture resistant and may be damaged if exposed to moisture. Secondly, they are more susceptible to corrosion and abrasion, and thirdly, they may not provide a secure connection between the wire and the solenoid valve. The 50 megohms insulation resistance reading specified in the contract documents is likely a requirement for several reasons, including firstly, safety. High insulation resistance helps prevent electrical leakage, which can be dangerous. Secondly, reliability. Systems with high insulation resistance are less likely to develop faults or failures due to moisture ingress. Thirdly, long-term performance. High insulation resistance ensures that the system will continue to function reliably over the long term. While it is important to strive for the specified 50 megohms reading, it is also important to be practical. In the field, it may not always be possible to achieve this reading due to factors such as soil conditions, moisture levels, and the quality of the installation. A minimum insulation resistance reading of 5 megohms is generally considered to be acceptable for a 24-volt irrigation system. This reading indicates that the system is well insulated and unlikely to experience electrical leakage or other problems. Therefore, it is recommended to firstly, specify type UF wire 14 AWG for all irrigation system wiring. Secondly, ensure that contractors are using UF wire as specified. Thirdly, verify the insulation resistance of the installed wiring using a megometer. And fourthly, accept an insulation resistance reading of 5 megohms or higher as practical for a 24-volt irrigation system. UF wire's resistance to moisture, sunlight, and abrasion is a critical factor. The tough outer jacket of UF wire provides a robust barrier against environmental elements that can degrade the insulation and lead to electrical faults. In contrast, individual 14 AWG wires lack this protective layer, making them vulnerable to damage, especially when directly buried in the ground. The American wire gauge, or AWG, system is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The higher the AWG number, the smaller the wire diameter. Therefore, a 14 AWG wire has a specific diameter and current carrying capacity suitable for the demands of irrigation solenoid valves. Using a smaller gauge wire could result in voltage drop and potentially damage the valves. Contractors sometimes opt for individual 14 AWG wires due to their lower upfront cost. However, this decision often proves to be a false economy. The long-term costs associated with premature wire failure, repairs, and system downtime can far outweigh the initial savings. By using the correct UF wire, the overall lifecycle cost of the irrigation system is reduced. Individual wires are more susceptible to moisture ingress, corrosion, and physical damage. Moisture can penetrate the insulation, leading to electrical leakage and short circuits. Corrosion can weaken the wire, reducing its conductivity and increasing resistance. Physical damage from rocks, roots, or other underground obstacles can compromise the insulation and expose the conductor. A contract specification requiring a 50 megohms insulation resistance reading is a crucial safeguard against these potential problems. Insulation resistance is a measure of how effectively the wire's insulation prevents electrical current from leaking to ground. A high insulation resistance reading indicates that the insulation is in good condition and provides a strong barrier against electrical leakage. A lower insulation resistance reading suggests that the insulation is compromised and may allow current to leak to ground. The three key reasons for requiring a high insulation resistance are firstly safety. Electrical leakage can pose a significant safety hazard, especially in public areas where people may come into contact with the irrigation system. High insulation resistance minimizes the risk of electric shock. Secondly, reliability. Moisture ingress can lead to corrosion and short circuits, causing the irrigation system to malfunction. High insulation resistance helps to prevent these problems and ensures that the system operates reliably. Thirdly, long-term performance. Over time, the insulation of underground wires can degrade due to exposure to moisture, chemicals, and temperature fluctuations. High insulation resistance ensures that the system will continue to function reliably for many years. Achieving the specified 50 megohms reading in the field can be challenging due to various factors, including soil conditions, moisture levels, and the quality of the insulation. Soil conditions can vary significantly, with some soils being more conductive than others. Moist soils tend to be more conductive than dry soils, which can lower the insulation resistance reading. The quality of the insulation also plays a crucial role. Improper splicing, damaged insulation, or poor connections can all contribute to lower insulation resistance readings. While striving for the specified 50 megohms reading is important, it's also essential to be practical and consider the specific conditions of the installation. A minimum insulation resistance reading of 5 megohms is generally considered acceptable for a 24-volt irrigation system. This reading indicates that the system is well insulated and unlikely to experience significant electrical leakage. If the insulation resistance reading is below 5 megohms, it indicates a potential problem with the wiring or installation. Further investigation and corrective action may be necessary to ensure the safety and reliability of the system. To ensure the long-term performance of irrigation systems, it's crucial to follow the recommendations of firstly, specifying type UF wire 14 AWG for all irrigation system wiring. This ensures that the correct type of wire is used for the application and that it meets the required specifications for moisture resistance, sunlight resistance, and abrasion resistance. Secondly, ensure that contractors are using UF wire as specified. Regular inspections and audits can help to prevent the use of non-compliant wiring materials. Thirdly, verify the insulation resistance of the installed wiring using a megometer. This test should be performed after the wiring is installed but before the system is put into operation. It helps to identify any potential problems with the wiring or installation before they can cause damage or safety hazards. Fourthly, accept an insulation resistance reading of 5 megohms or higher as practical for a 24-volt irrigation system. This provides a reasonable balance between the specified requirements and the real-world conditions of the installation. By following these recommendations, it is possible to ensure that irrigation systems are safe, reliable, and operate efficiently for many years. When performing insulation resistance tests, it's important to use a calibrated megometer and follow the manufacturer's instructions carefully. The megometer applies a high voltage to the wire and measures the amount of current that leaks through the insulation. The insulation resistance is then calculated based on the applied voltage and the measured current. Before performing the test, it's important to disconnect the wire from any equipment or power sources. This prevents damage to the equipment and ensures accurate readings. It's also important to ensure that the wire is clean and dry, as moisture and dirt can affect the insulation resistance reading. When interpreting the results of the insulation resistance test, it's important to consider the length of the wire. Longer wires will typically have lower insulation resistance readings than shorter wires, due to the increased surface area of the insulation. It's also important to consider the age of the wire. Older wires may have lower insulation resistance readings due to degradation of the insulation over time. In some cases, it may be necessary to perform a polarization index test to assess the condition of the insulation. The polarization index is the ratio of the insulation resistance reading after 10 minutes to the insulation resistance reading after 1 minute. A high polarization index indicates that the insulation is in good condition, while a low polarization index suggests that the insulation may be deteriorating. If the insulation resistance reading is below the acceptable limit, it may be necessary to replace the wire. However, in some cases, it may be possible to improve the insulation resistance by cleaning the wire and applying a sealant to the insulation. It's also important to address any underlying causes of the low insulation resistance, such as moisture ingress or damaged insulation. Proper installation techniques are essential for ensuring the long-term performance of irrigation systems. Wires should be buried at the proper depth to protect them from damage. Splices should be made using waterproof connectors to prevent moisture ingress. Wires should be supported properly to prevent them from sagging or rubbing against other objects. Regular maintenance is also important for maintaining the integrity of the wiring system. Inspections should be performed periodically to check for signs of damage or deterioration. Damaged wires should be repaired or replaced promptly. The irrigation system should be winterized properly to protect it from freezing temperatures. By following these best practices, it's possible to ensure that irrigation systems are safe, reliable, and operate efficiently for many years. Selecting the right type of wire for irrigation systems involves several important considerations. Understanding the properties of UF wire and the reasons for its specification in public park systems is crucial. The choice of wire gauge, particularly 14 AWG, is dictated by the current requirements of the solenoid valves. Proper installation techniques and adherence to contract specifications are also paramount. While contractors may be tempted to use individual 14 AWG wires for cost savings, the long-term risks associated with this practice outweigh any initial benefits. UF wires' moisture resistance, durability, and ability to provide secure connections make it the preferred choice for irrigation systems. The 50 megohms insulation resistance requirement in contract document serves as a crucial safeguard against electrical leakage, faults, and failures. While achieving this reading in the field may be challenging, maintaining a minimum of 5 megohms for a 24-volt system is generally considered acceptable. Regularly verifying insulation resistance with a megometer and following recommended installation practices can ensure the safety, reliability, and longevity of irrigation systems in public parks. In summary, the use of UF wire, correct gauge selection, adherence to specifications, and regular testing are all essential components of a well-designed and maintained irrigation system.